Aristotle was a 4th century BCE Greek philosopher who sought to understand the world through reason, observation, and systematic classification. Unlike his teacher Plato, who emphasized abstract ideals, he focused more on the concrete world. Aristotle made important contributions to the development of the science of logic. A central feature of his philosophy is the theory of the 10 categories. These are 10 fundamental ways in which a thing can be described: substance, quantity, quality, relation, place, time, position, state, action, and affection. Aristotle described the world as made up of substances that change according to 4 causes: material, formal, efficient, and final. He believed everything in nature has a purpose, or final cause. In ethics, Aristotle focused on how we can achieve happiness, or human flourishing, through practicing virtue. He believed the good life means living virtuously and in balance between excess and deficiency. His ideas helped shape Western science, logic, ethics, and politics for centuries. Galileo Galilei was an Italian researcher and philosopher who revolutionized science by combining observation, experimentation, and mathematics. He championed the heliocentric model, challenging church orthodoxy with evidence from his telescope. He argued that nature speaks in the language of mathematics and that scientific inquiry should be based on reason and experience, not tradition or authority. Galileo's trial by the Inquisition made him a symbol of intellectual freedom. His philosophy laid the groundwork for the scientific method and modern empirical thought. Isaac Newton was an English physicist who revolutionized science with his formulation of 3 laws of motion, which describe how objects move and interact. These laws became the foundation of classical mechanics and remain central to physics today. His law of universal gravitation explained how all objects attract one another, from falling apples to orbiting planets. This unified celestial and terrestrial motion under one principle. Newton also made major contributions to optics, showing that white light is composed of colors, and he helped invent calculus to describe change mathematically. His work suggested that nature operates according to universal laws discoverable through reason and experimentation. Carl Linnaeus was an 18th century Swedish naturalist. He is perhaps best known for creating the system of binomial nomenclature, the standardized way we name living organisms today. His system assigned every species a 2-part Latin name, genus and species, which made scientific communication across languages far more precise. This approach laid the groundwork for modern taxonomy. The Swedish scientist organized nature into a hierarchy which included kingdoms, classes, orders, genera, and species, reflecting what he saw as a fixed order in the natural world. Although later evolutionary biology challenged his belief in the immutability of species, the structural logic of his classification system remains central in biology. The Swedish biologist's work exemplified the Enlightenment's drive to catalogue and systematize knowledge, and his rigorous approach helped future scientists frame deeper questions about the relationships and origins of life. Antoine Lavoisier, an 18th century French chemist, is often called the father of modern chemistry. He helped transform the field from mystical alchemy into a quantitative science. His experiments suggested that matter is neither created nor destroyed, establishing the law of conservation of mass. The French scientist revolutionized our understanding of chemical reactions. His work indicated that combustion and respiration are not the release of a mysterious substance called phlogiston, but rather chemical processes involving oxygen. By emphasizing precise measurement and experimentation, he made chemistry a more empirical and rational discipline. He also introduced a new chemical nomenclature and helped define elements as fundamental substances that can't be broken down. Though he tragically died during the French Revolution, his legacy endures. His ideas helped change how we do chemistry and how we think about the nature of matter and transformation. Charles Darwin, an English biologist, introduced the theory of evolution by natural selection, arguing that species change over time due to inherited traits that enhance survival and reproduction. This idea challenged traditional views of fixed, divinely created life forms. In On the Origin of Species, Darwin used evidence from geology, paleontology, and biology to argue that all species share common ancestors. His theory explained the diversity of life as a gradual, adaptive process. Darwin's work not only transformed biology, but also had far-reaching effects on philosophy and many other sciences such as psychology, raising deep questions about humanity's place in nature. James Clerk, Maxwell, a Scottish physicist, unified electricity, magnetism, and light in one elegant framework, Maxwell's equations. These four equations describe how electric and magnetic fields interact and propagate, indicating that light itself is an electromagnetic wave. His theory predicted that electromagnetic waves move at the speed of light, suggesting that visible light is just a small part of a much broader spectrum. This opened the door to radio, X-rays, and more. Maxwell's work significantly improved our understanding of electricity and magnetism and helped develop theoretical physics. His equations are often considered second only to Newton's laws and Einstein's theory of relativity in their impact. Marie Curie, a Polish-French physicist and chemist, was a pioneer in the study of radioactivity. Along with her husband Pierre, she discovered two new elements, polonium and radium, showing that atoms could break down and release immense energy. She developed techniques for isolating radioactive isotopes, which eventually led to new ways of treating diseases and laid the groundwork for much of nuclear physics and chemistry. Her research also helped redefine the atom as a dynamic structure, not an indivisible unit. The pioneering scientist was the first woman to win a Nobel Prize, and for the time being the only person awarded in both physics and chemistry. Her life exemplified curiosity, rigorous science, intellectual courage, and humanitarian impact. Albert Einstein was a German-born theoretical physicist who redefined physics with his theory of relativity. According to his special theory, space and time are not absolute but relative to the observer. This led to the famous equation E equals mc squared, indicating that mass is a form of energy. His general theory of relativity expanded these ideas to include gravity, proposing that massive objects bend space-time itself. This replaced Newton's view of gravity and accurately predicted phenomena like the bending of light near stars. Einstein also made foundational contributions to quantum theory, especially the photoelectric effect, which showed light has particle-like properties. His work helped reshape physics, revolutionized our understanding of the universe, and influenced many later scientists and philosophers. Niels Bohr was a Danish theoretical physicist who revolutionized atomic theory with his model of the atom, proposing that electrons orbit the nucleus in discrete energy levels. When electrons jump between levels, they emit or absorb specific amounts of energy, explaining atomic spectra. He introduced the principle of complementarity in quantum mechanics. Particles like electrons exhibit both wave and particle characteristics, depending on how we observe them. This was a cornerstone of the so-called Copenhagen interpretation. The Danish physicist also emphasized limits to what can be known in quantum systems. His work helped reshape physics, forcing a rethinking of reality itself, and influenced both science and philosophy in profound ways.